Today, we'll be taking you on a step-by-step approach on installing a solar system on this facility. So, the system we will be building today is a 20 kVA by 96 volt inverter system. But before we start going into the details, we first needed to survey the site and do a proper load analysis to know the kind of system to design, of course. After site survey and proper load analysis, we have deduced that the system would be able to carry the firm's load with a 20 kVA inverter, which equivalents to a 16 kilowatt rail power when multiplied by a 0.8 power factor. Of course, we went back home to whip up a diagram for what we were going to build before actually building it. I'll place the image on the doc file that I'll be linking in the description below. So the document file is meant to contain some of the materials used for the build. So I'll explain the diagram while I take you through the process of how we came to achieve this project. So, after ordering the devices and materials we needed, they were loaded up into the car. Well, as you can see, the market is quite a busy place.
Stop playing.
So our goods arrived and we took it to ourselves to load them all out.
Arrival of the system for the 20 kVA installation with 32 solar panels from Vinet Inventing. We do what we know how to do best. So this is the 20 kVA 96 volt inverter. So arrival of the 20 kVA cattle inverter. Okay, these are the batteries. Solar panels, inverter. Okay, this is the charge controller.
So yeah, we're done offloading for today. Day 1 complete. Now, let's talk about the major materials / equipment that we use to achieve this project. First, we have a 3-phase 20 kVA inverter. So a 20 kVA 3-phase inverter will be needed to convert the DC electricity generated by the solar panels into AC electricity that can be used to power electrical loads. Secondly, we've got the trunk pipes. So this is for properly tucking and hiding the cables to obtain any work. Thirdly, we have the charge controllers. The charge controllers is a sine wave dual input controller which accepts a maximum of 195 volts as input voltage. It gives off 96 volts by 100 amp as maximum output voltage. Number 4, the solar panels. We have a total of 32 high quality solar panels having a short circuit voltage of 40 volts and an open circuit current of 10 amps. Number 5, we've got the 12 volt tubular batteries. There are a total of 16 batteries. Each is a 12 volt by 200 amp hour battery. 8 are connected in series, making up one string, while the second string is in parallel with the first. Number 6, the connecting cables. Now what would we do without these cables used for connecting each device to function properly? These include the solar panels and etc. And the last but not the least, battery racks. There are 2 sets of battery racks for storing batteries. Now these are just some of the major materials that we used to achieve this project. So it's day 2. Starting to upload the panels and just enjoy the process.
From Vinet Invent Limited. It's progress. We see the magic after the whole system. So the solar panel installation ongoing. The battery installation ongoing.
What better way to start an installation than to start from the top? So, talking about the solar panels. Each solar panel has a rating of at least 40 volts by 10 amps. So, we connected 4 solar panels in series and another 4 in series, and we connected those 2 4s that are in series in parallel with each other, which sums up to a total rating of 160 volts by 20 amps. While voltage in series adds up, current in parallel adds up. And we did this 3 extra times, sending the positive and the negative of 2 of these connections to one charge controller, and the positive and the negatives of 2 of the extra connections to the other second charge controller. So the voltage that the charge controllers bring out is a maximum of 96 volts. So we connected the charge controllers in parallel to obtain a rating of 96 volts by 80 amps. Talking about the batteries. The rating of one battery is 12 volts. 12 volts by 220 amps. So we connected 8 batteries in series to make up one string of the batteries, and we connected another string, a second string, and connected the 2 strings in parallel to double the current. After doing this, we connected the positive of the battery to the positive of the charge controller, and the negative of the battery to the negative of the charge controller. After doing this, the cables were run through and to the inverters and were connected to the battery terminals of the inverter. This, of course, was able to power up the inverter. After ensuring these connections, we sent out a 3-phase wire to a changeover system for the solar system, so that when the changeover is brought down, the system will be operating on the inverter and also with a PHCN or a generator. Power will flow through the inverter and then go to the load. That means the grid the gen has to go through the inverter, charge the batteries before meeting the load. But when it is up, the changeover is up, it will be operating just on a normal grid or a generator system.
Okay, testing of the inverter. The 3 phases are complete. The lighting points are pouring. Okay. Process running of the system with inverter.